Welcome back, everyone, to WUWT Live TV. We're going to be talking now with Dr. Ross McKitrick of the University of Guelph, who is an economist and who has been following the climate debate for quite some time, has published a number of scientific papers on the subject dealing with the economics as well as the impacts of global warming on the economy and on people. He's joining me now live from his office at the University of Guelph. Welcome, Dr. McKitrick. Appreciate you joining us today.
Oh, it's my pleasure, Anthony.
You had spent a lot of time writing papers on this, and you've been involved for quite a while, I think for at least 10 years or more on this. What got you started into this? What made you start looking into climate where primarily you were an economist first?
Well, this goes back to the 1990s when I was doing my PhD in economics at the University of British Columbia, and that was really the early stages of people talking about some of the policy implications of trying to reduce greenhouse gas emissions. And there weren't many people, at least in Canada, working on the topic, and I got interested in it and did some economic modeling of things like carbon taxes and other policies. And then I've stayed with the issue since then, and it's the kind of issue where you have not only the economic issues on the table, but a lot of physical science issues. And the thing that tends to tie them all together is they're very data-intensive kinds of questions. And so as an economist, I had lots of statistical training, and I found some of the economic issues interesting and some of the science issues interesting. So for instance, when Steve McIntyre and I were working on the hockey stick issues, that was all related to the statistics. And you mentioned impacts kind of work, and you've done work on surface temperature data quality, and I've done a bit of work on that as well, but more from, again, looking at the large-scale statistical questions. It's really just a matter that there's always something new and always something interesting to pursue. What I'd like to talk about this time is really more focused on the economic side, and in particular, there are a number of policy issues that I find just keep coming up because people don't necessarily follow the logic very carefully on the policy issues, and this is where I think economics really does have a good contribution to make.
I was wondering, when you first got started in this, would you describe yourself as a skeptic initially, or did that come later after you'd looked at the original global warming data and some of the papers that had been published on it?
No, I certainly was not a skeptic. I can look back on some of my early teaching notes when I started here at the University of Guelph, when I was teaching the unit on climate change in my environmental economics course, and I was really just giving people the boilerplate edition, just taking some of the standard material. I even had students reading a Stephen Schneider article from Scientific American. I think what began a kind of intellectual migration on this was I'd seen lots of presentations at conferences and workshops where, because it's an interdisciplinary topic, we'd have a scientist come and present on the science side, and then there'd be a few of us speaking on the economic side. And when I started looking into it, and one of the first things that struck me when I saw the satellite data was, okay, here's obviously a very important data set, and it gives us a somewhat different message than the surface data set. Why haven't I been shown this before? I mean, why was this information kind of filtered out, and what else has been filtered out from these kinds of presentations that I'd been seeing? And so I just started looking for myself, and before long I just found this was the issue over and over. I've been told everything is settled, it's all nice, neatly bundled up, all the issues are simple, the science is all settled, and yet you don't have to look very far to discover that's not really true, that there's all kinds of questions. There's conflicting data sets, there's uncertainty, there's underlying uncertainty about some of the basic science issues, and then you get into the empirical questions where there's just a lot of difficulty in figuring out what the message is from the data. So that was really the origins of how I got involved in some of the research that I did, and led me to take views that depart in a lot of respects from those early boilerplate consensus summaries.
I understand, and you've taken quite a bit of flack from a lot of people over some of those publications. I know that you had lots of difficulty with Steve McIntyre getting the original M&M critique of Dr. Michael Mann published. Was it surprising to you that you had so much difficulty getting that thing published initially?
Well, actually, I should say our first paper in 2003, it wasn't all that difficult, but that was because we chose to publish in Energy and Environment, where we knew that they weren't going to be put off by the topic just because of what we were arguing. I've had more difficulty getting work published related to problems in the surface temperature record. Um, Steve and I certainly had an uphill battle getting our message across with the hockey stick material, but in the end, uh, that was such a contentious issue that I think even, we got into geophysical research letters, and there I think just the recognition was we'd done our homework, we'd really put together a solid argument, and there was no holding it back. On the work that I've done on the surface temperature record, though, that's where I found sometimes you just hit a brick wall in terms of what climate journals are willing to publish, and there's no getting around it. Doesn't matter how good or how strong your results are. And so in that case, I've had to go to statistics journals or economics journals to publish that, because you have to move outside the field to where people aren't so heavily invested, aren't so emotionally invested in the subject, and then they'll just evaluate the paper based on the quality of the reasoning.
I understand. I've experienced some similar things in my own work with the surface temperature record. Okay, now you have a PowerPoint presentation you're going to show us today, which is titled Energy, Pollution Control, and Economic Growth. And
Yep.
I'm going to switch that over at this point for you, and you can take it from here to narrate it. It's on live. Go ahead.
Okay, well, yeah, as my title says, Energy, Pollution Control, and Economic Growth. These are big topics at any point in time, but I think especially now in the aftermath of the election in the US, there's a lot of questions about what direction is energy policy going to go. Here in Canada, these are big issues as well with our energy sector. And to give you the quick summary, what I want to cover is, first of all, a reminder that energy use is not just a byproduct of economic growth, it's a cause of economic growth. So you have to think very carefully about your energy policy. Constraining energy use is going to limit economic growth. And I think, as I'll explain, that's a point that's kind of been forgotten as people think about changing the mix of energy and changing the cost of energy. Fossil fuel-based energy has a clear cost advantage. That's historically always been the case. It's likely to continue to be the case, but it does raise the pollution concerns that we're talking about now. In order to navigate those pollution concerns and to think about them clearly, I want to divide them up into three different categories, and I'm thinking here of air pollution emissions primarily. First of all, there are conventional air pollution types, indirect air pollution types, and then CO2 as a category in itself. I'll explain what these three categories mean. Economic analysis has some useful principles to put forward that can reconcile economic growth and environmental protection. And finally, a message I think is going to emerge fairly clearly is that the focus on renewable energy is a very inefficient way to respond to environmental concerns. So if the environment is brought forward as the rationale for renewables policy, I'm going to hopefully show you that that's not a very valid basis for renewables. Okay, moving on now to my first point. Electricity, which we take for granted all the time, is really, in Western countries, it's the engine of liberation. An interesting fact here is that the spread of inexpensive electricity is really what's responsible for, first of all, allowing children to get educated and allowing women to enter the workforce. The average U.S. household in 1900 spent about 58 hours a week doing routine household chores. That's down to about 18 hours a week now, and the reason is electricity. Inexpensive, abundant, safe electricity. So the adoption of large appliances is an explanation for about half the rise in the female labor force participation over the 20th century. I could go on the research that's been done there, but I think you get the point that a lot of the social progress that's happened in countries like the United States of the 20th century really ties to the abundance and low cost of electricity. So then, if we think about electricity, or energy use in general, it goes up as the economy grows. The two sort of march together in step. And then we can think about, well, what causes what? Does energy use, is it just a byproduct of economic growth like jewelry, or is it something more fundamental? If you take the view that energy is just a byproduct of growth, then it means you could think about limiting the consumption of electricity and your economy would still grow. Okay, you could limit the consumption of jewelry and it wouldn't affect economic growth because jewelry is inessential. And a lot of what I hear politicians talking about when they're talking about conservation programs and demand management programs and that sort of thing, they're thinking energy use is just this fluff that the economy throws off as it grows, and you could limit that, and the economy would just keep growing. But there's another way of looking at it, and that is energy use is an input to economic growth, an essential input. And in this kind of view, if you start to limit your access to energy, if you limit your availability or you make it more expensive, then you're going to cut into economic growth, and in turn, you're going to start to reduce your standard of living, you're going to raise consumer prices and that sort of thing. So we have a dual causality here, a what causes what kind of question. And this is something that a lot of economists have been looking at in the last few years. Now there's a statistical term, a vector autoregression, which is the sort of empirical model that economists use to diagnose the direction of causality. And when we look at energy use and economic growth, the favored view that would emerge in the data is energy consumption causes economic growth, but growth does not necessarily cause energy consumption. So in other words, it's that second view that has more support in the data. And one economist, not Nicholas Stern, a different Stern, who looked at this, he summarized the data by saying energy Granger causes GDP. In other words, energy is the input to economic growth, either unidirectionally, as indicated by the first of his three models, or possibly through mutually causative relationship. Energy is a limiting factor in economic growth. Shocks to energy supply will tend to reduce output. So that's really the key there, that energy is a limiting factor in economic growth. Now, if we think about the policy implications, then we can say that measures that deliberately limit energy availability by either artificially increasing its cost or making the supply less reliable will therefore diminish economic growth. Now, I think most people would say, you know, that makes sense. There's nothing too complicated about that. But the question is, why would we do it? Why would you have policies that deliberately make energy more expensive, less abundant, less reliable? Back in the 1970s, there was this fear of looming energy shortages, and that was a justification for a lot of policies. Didn't make a whole lot of sense to me, the idea that because we're worried that energy is going to be more scarce and more expensive in the future, we'll make it more scarce and more expensive today. And those policies, however, got put in place, and a lot of them never really got rolled back. But today we don't hear about that so much. We've pretty much figured out that energy, at least fossil energy, is in abundant supply, and we're not facing critical shortages. Now it's the pollution and climate change issue is the one that comes forward. So people would contemplate making energy more expensive and less abundant because of the environmental issue. So let's go into that in a little bit of detail. There are three types of air contaminants you need to understand. There are direct air contaminants. So we're thinking there of sulfur dioxide and NOx, or the nitrogen oxides, carbon monoxide, and particulate matter, or PM. There are indirect air contaminants, and these would primarily be ozone and aerosols, or ultrafine particulates, and CO2, carbon dioxide. Now the reason that middle category is called indirect air contaminants is they're not emitted. So we don't have smokestacks emitting ozone. What you have are smokestacks emitting other gases that in the atmosphere turn into ozone. And the same with aerosols. A lot of them are not emitted directly. Instead, they're formed by chemical reactions involving other types of emissions. Sulfur dioxide, though, or SOx, as it gets called, there's a few sulfur oxygen compounds involved. Those are directly emitted. So when we're worried about the amount of sulfur dioxide in the air, it's directly coming out of smokestacks in that form. and it's regulated in that form. Same with carbon monoxide coming out of tailpipes. It emerges as carbon monoxide, and that's the form in which it's regulated. And then CO2 is a different category for reasons I'll get into. Dividing up in these three categories is important because from the policy point of view, these are three very different challenges. The direct air contaminants are relatively simple to control now. The indirect air contaminants are kind of challenging to deal with, and the CO2 is very challenging to deal with. And it's important to keep this in mind because sometimes people look at the CO2 case and they'll say, well, look, in the United States, you've cut your sulfur dioxide emissions by about 2/3 since the 1970s, so why can't you do the same with carbon dioxide? Well, because they're different issues, different technology, different chemistry involved, and you need to think about them in separate categories. So let me give you some data here on the U.S. history of air pollution. This graph shows real GDP, U.S. real GDP per capita, in other words, real average income on the horizontal axis. On the vertical axis, it shows total U.S. particulate emissions. And this data set runs from 1945 to 1998. The data after 1998 continues to go down. I just happen to have this data set at hand. What you can see is that as income grew in the United States, particulate emissions fell, and they fell more or less continually over the whole period. This comes as a bit of a surprise when I show this to students because they've been raised to think, well, economic growth is bad for the environment, and as the economy grows, you get more pollution. But it's really not as simple as that. In this case, economic growth paid for pollution control in the United States, at least in the form of the scrubbers and the smokestack treatments that reduce particulate emissions. Now, if we look at a different contaminant, though, this is carbon monoxide emissions. So there you had two phases, really. There was an earlier phase where as the economy was growing, income was going up, and carbon monoxide emissions went up. And there is sort of a race between prosperity and technology. As people got wealthier, you had more cars on the road, more industries opening up. It took a while for the emissions control technology to catch up. But by about 1970, it had caught up, and the emissions control for carbon monoxide has been very effective, especially things like catalytic converters on cars. And now you have increasing income and decreasing carbon monoxide levels. Showing you the same kind of data in a slightly different format. The top line there in this graph here, I don't know, oh, you can't see my mouse, but the top line going up is income, real GDP, and real consumption in the US. Everything's indexed to begin at 100. By the end of the 1990s, the economy has grown about sixfold in the United States. The other lines show the progress of total emissions. So the next one down is what's called NOx emissions. They grew up until about 1975, and they were stopped at that point, and then they've stayed constant. The other air contaminants grew up until about 1970, and then they started tapering down, except for particulates, which just went down over the whole period. So by the end of the 1990s, even though the US economy had grown 6 times larger, total conventional air pollution emissions were below where they were at the end of the Second World War. And that's because you guys did a great job of inventing catalytic converters and scrubbers for smokestacks and low NOx burners and other kinds of treatments that let you continue to run your power plants, continue to build factories, continue to put cars on the road, and yet be reducing the emissions in the process. So this is a story, I think, a good news story in the United States, just of technological progress. It's reflected in Canadian data and European data as well. You have economic growth and you have air pollution going down. Now, these are the direct air contaminants. If we look at the indirect air contaminants, the story is a little different. This is the concentration of ozone, monthly average ozone levels in Toronto in this case. And the data here runs from 1974 to the end of 2002. And you can see, first of all, there's an annual cycle. There's an up and down cycle. When you get to the summer, the air is, it's got more precursors in it, more sunlight, which you need for producing ozone, and the level goes up. There's no real trend there. Maybe from the 1990s to the present, the trend has been up slightly in terms of the average. There's a red line across the top there, though, that shows 65 parts per billion. That's called the Canada-wide standard. That's the clean air target for Canadian cities. And I think the data here will be pretty much the same for a lot of US cities as well. There's the up and down annual cycle, but your average ozone levels are pretty low compared to the clean air standard. What you don't see in this data, though, is that on some of those summer days, the peak goes way above 60 parts per billion or 65 parts per billion. You get occasional spikes in ozone formation. They don't last for long, just a couple of days. And during those high ozone episodes, the air can get kind of sticky and uncomfortable in a city under an inversion or something like that. These are monthly averages, so you don't see that. But I'll show you another data set which gives you an idea of the progress on dealing with those spikes. So this graph here shows US annual violations in carbon monoxide, CO, and ozone per monitoring station from 1974 to 2002. Now you get a violation only if you have one of those spikes that jumps up above the 65 part per billion mark. So back in the 1970s, every air quality station in the United States would have at least 10 on average violations per year. So you'd have 10 days per year where you get heavy smog episodes, basically. By the end of the 1990s, that average has dropped down to about 1 per year per station. And I don't have the data coming up to the present, but I wouldn't be surprised if it's down around a half on average per station. So even though the average ozone level hasn't gone down much across US cities, those spikes have been brought under control. They're a lot less frequent and a lot less acute. So that's the direct and the indirect air pollution issues. We come now to CO2, and that's where we have to kind of scratch our heads. How do you control CO2 emissions? There are no scrubbers. If you're going to run a coal-fired power plant or an oil-burning factory or anything like that, you can control the sulfur, you can control the particulates, you can control the NOx. But CO2, there's no scrubber for it, and even if you did extract it from the smoke, there's nowhere to put it. It emerges as a gas, and except if you try pumping it underground, which is very expensive and very energy intensive, there's really nothing to do with it except to release it somewhere else. So you don't have the same control options. Also, it's not related to the efficiency of the burn. If you improve the efficiency of your fuel burning, you'll reduce some of the direct emissions like NOx, but it doesn't matter how efficiently you burn the CO2, it's all going to emerge in the air one way or the other. The other problem with controlling CO2 is the CO2 per unit of energy is highest for coal, then next for oil, and then for natural gas. But of the three types of energy, coal has the biggest price advantage. It's the cheapest and the most abundant of the three. So here is a graph showing you real fossil fuel energy prices in the US market from 1949 to 2010. The blue line at the top is natural gas, and you can see that historically it's been the most expensive of the three. And even with the recent price drop in the last couple of years, so the price has fallen by half for natural gas, it's still expensive compared to gas and oil, at least its overall trend. The yellow line is the crude oil price, and it hasn't been as volatile as natural gas, but it's still become more expensive over time. And then that black line is good old king coal, and you can see it's a pretty low and steady price for the use of coal. All those price indexes are set to start at the level 100. So you can see that coal, in real terms, is no more expensive now than it was in the 1940s, whereas oil and natural gas have gone up between 4 and 10 times as much in price.
Dr. McKitrick, I was wondering if I could ask you if natural gas prices are expected to plummet related to shale gas.
Yes. So there's already been a huge drop in natural gas prices. And all the indications are that price drop is permanent, and I think you can expect to see even more drops as some of the production locations that are now in development come online. Whether they go a whole lot farther down, I think it's less likely, just because our operating margins in the natural gas sector now are pretty thin. So, the shale gas and fracking and so on is not cheap. So, I don't think you'll see natural gas drop to drop by another 50%, for instance. I might be wrong, but I think you'll see a little bit of reduction from here, but
Thank you.
not the things we've seen the last couple of years. So anyway, the price advantage for coal is shared by fossil energy in general. Um, if we look at world energy production, this pair of graphs here compares 1973 and 2009. And what's interesting is for all the technology that's changed since then, fossil and nuclear have kept their share constant at about 87%. So oil has gone down, coal has actually gone up a little bit over that time. Natural gas has gone up from 16 to roughly 21%. Nuclear, which was not a big player in the world energy scene in 1973, is now accounting for about 6%. And then the others, hydro and biofuels, really haven't expanded their share very much. So if you take fossil and nuclear together, they still account for the lion's share of world energy production, even after 36 years of change. If we go to the here we see the fossil sources continue to dominate. Again, you've had a lot of technological change. You have reduction in the oil share. You can see in the graph there from 35% down to 15%. Coal and natural gas are holding steady at around 30% each. Nuclear has gone up in the United States. It's now about a 10% player in U.S. energy production. And then hydro at 5%. Renewables holding their historical spot at about 5%, except there's a bit of an uptick at the end there. Let's see, it's really driven by the subsidies of the past few years. Otherwise, again, in the U.S. sector, fossil energy, coal, natural gas, and oil continue to dominate the energy production picture, and they can be expected to do so in the future. So, some conclusions to draw on this material. Where nations have the choice among energy types, fossil energy dominates. Nuclear has grown, although it's still a minor share globally. Among the fossil sources, coal is the most economical, and renewable sources are only a small contributor. They emerge late in the sample, and it's primarily driven by government subsidies. Okay, so that takes us back to the pollution issue. We have fossil energy. It's going to continue to be with us. It has a strong cost advantage, and within fossil, coal bigger. So now I want to talk about how pollution and the economy kind of fit together, at least how economists think about this issue. First thing to point out is when we talk about the economy, when economists talk about the economy, we're thinking about the price system. And I'll emphasize this a couple of times that prices are really the variables of interest for economists. The price system, the use of prices to allocate goods and services, has been shown by long experience to be the most efficient way to do it. It's not really a point that I need to elaborate on. I suppose 20 years ago it would have been more controversial, and in some countries it's still kind of controversial, but we'll just take it for granted. It's understood that the free market, the price system, is the most efficient way to allocate goods and services. The trick is there's some goods and services like energy where all of a sudden people forget this. They think for some reason with respect to energy, it's got to be centrally planned. And that's not really true. But the same processes that make the price system efficient apply to energy as well. And the existence of pollution externalities doesn't undermine that fact. So with regard to energy markets, you've got supply side and demand side. On the supply side, investors have to make long-term plans based on their expectations about fuel prices and demand conditions. Competitive incentives operate, so firms that are selling energy, either electricity or fuels, want to get their product to market at the lowest possible cost, so they'll be competitive. And then households and firms are going to make decisions about the kinds of appliances, equipment, buildings they're going to put up based on their expectations of prices. Okay, so um, the two possible problems within the energy sector that economists are interested in are there's the monopoly issue and the pollution externalities issue. The natural monopoly issue is simply that for some of these activities, inevitably one large player is going to emerge. So this really applies to transmission of electricity, for instance. You're not going to have firms competing, putting up parallel hydro lines and so on. You really want one large firm to do it. But that's not a big problem to deal with in terms of economics. You just have a regulated monopoly in cases where there's no way to avoid one large player from emerging. But on the basic production side, that's not really an issue. You can have competitive markets for energy production. Pollution externalities is a different issue there um, because you have power generation generating emissions to the air, but there are policies that can address this. When we talk about the policies and trying to get clear thinking on this, there are two principles that I want people to understand. The first is the principle of targeting, and the second is the pricing principle. So to begin with, on the principle of targeting, this is the basic idea, and I'll give you examples. But the reason I'm going into this is no matter how obvious this turns out to sound when you're just listening to it, thinking about it at leisure like we are, anytime the government gets to work on this issue, these are the principles that immediately get thrown out the window. And as a result, we get some really crazy thinking going on about energy policy. The principle of targeting, having to do with pollution especially, is to minimize the cost of achieving a policy goal, you apply the policy instrument directly on the issue of concern. You don't try to control one variable by applying policies to other variables that are only partly related to it. Okay, so that seems like a pretty obvious point, but let me explain why it doesn't seem to be obvious in practice. So suppose that you're interested in sulfur coming from power plant smokestacks. If that's what you're interested in, the obvious answer is regulate sulfur dioxide coming from plant smokestacks. But what happens instead is governments start to regulate indirectly through the kinds of appliances that people buy or the kinds of light bulbs that people buy, in the hopes that in some way, by controlling the kind of light bulb that you buy, that's going to have an effect on the sulfur dioxide coming out of smokestacks hundreds of miles away. It's this kind of indirect measure that substantially exaggerates the cost of environmental policy. So when we had the whole, or when you had the whole discussion about whether you should let people choose what kind of light bulbs they're going to use in the privacy of their own homes, the issue constantly came back to this concern about pollution coming out of smokestacks. But you already have regulations for this pollution coming out of the smokestacks. You have hard caps on sulfur dioxide levels in the United States. Another example in the US would be something called New Source Review. There's a picture there of a power plant with smokestacks. They are limited in the amount of sulfur they can release. They have to buy permits. It's part of a tradable permit system. But at the same time, if they wanted to repair some of the equipment in their plant, they can't just go out and buy a new boiler, for instance, and put it in, do some upgrading. The rules say that if they're going to do that, they have to go through this expensive legal review to ascertain whether that amount of equipment replacement constitutes building a whole new power plant. And if it's a whole new power plant, then they're subject to a different set of regulations on the type of equipment they're allowed to use. But why do all that when you already have the cap on sulfur dioxide emissions? It wouldn't make any difference one way or the other to overall air quality. It's regulating an indirect variable in the hopes that it'll have some effect on sulfur dioxide emissions, but it's completely redundant, and it's the sort of thing that makes pollution policy artificially expensive in countries like the United States. Okay, so just sort of drawing that point to a close, any emissions control achieved using indirect measures are going to be more expensive and more inconvenient than the results of direct controls. And once you have direct controls in place, there's no need for all these indirect measures. And I would just say to policymakers and so on, once you've got the targeted variable in mind, once you've got the instrument in place that targets what you're interested in, then leave people alone. Don't go regulating their washing machines and their light bulbs and everything else. Just focus on what you're actually interested in. Okay, the next issue is the pricing principle, and here we get into a bit more sort of pure economics. Um, the optimal pollution control policy consists of a price on emissions that reflects the marginal damages of those emissions. So that part sort of makes sense to economists. Uh, the other part, though, that needs to be emphasized is once you've got that in place, efficiency requires that you have nothing else. So I noticed in the news today that there's still talk of a carbon tax in the United States, um, and I think the Grover Norquist group got in trouble for saying that, well, if you have a carbon tax and you use the revenue to reduce income taxes, that may not qualify as a new tax. Um, be that as it may, anyone who wants to advocate for a carbon tax, if they're going to argue that it's an efficient policy from an economic point of view, you can't just say, let's have a carbon tax. You also have to list all the other regulatory measures that you will remove prior to putting the carbon tax in place. Because an emissions price is only efficient if it's the only instrument. If you have an emissions price on top of all the other regulatory instruments, uh, then the emissions tax just adds to the inefficiency of everything else. So the pricing principle here is if you want the most efficient means possible of controlling a type of emissions, then you have a simple price that reflects the marginal social cost of those emissions. Okay. There's one other point here that I want to try to drive home, and again, it's among economists, the stuff is all dead obvious and very simple, but in the policy realm, this stuff is all forgotten, and as a result, you end up with policy discussions that really exaggerate the cost of what you want to accomplish. Markets consist of two variables, prices and quantities. Now, everybody knows what the quantity means, and for the most part, people know what prices mean. If you're talking about the market for toasters, for instance, everybody knows what the price of a toaster is or what it means. But it's worth reminding ourselves that it signals the marginal willingness to pay, the amount someone is willing to pay for one more unit. Now, when we talk about pollution, pollution always has a price. The problem is it's usually not observed. And so when you talk about pollution policy, uh, you, uh, most people will think just in terms of the quantities, whereas economists, when we're talking about this, we're mostly thinking in terms of the prices. It's just the prices aren't observed. In any market, there's an inverse relationship between the price and the quantity. So the price being how much you'd have to pay for something, and the quantity being how much you're prepared to buy. And there's a price associated with emissions, even if we don't observe the price. So if there's no regulations in place, like the case with carbon dioxide right now, there's no regulations basically at this point, except a few indirect measures. But that means that firms can emit as much as they want and they don't pay for it. But if there was a restriction on emissions, it would be like having this barrier in place that says the quantity can't go past a certain point. Once you do that, then that means there's also implicitly now a price. And the price reflects how much a firm would be willing to pay to be allowed to emit a little bit more. Now, from the economics point of view, like I say, we're more interested in the price than the quantity typically. And the idea is that if you put a price in place, then you'd get the same quantity outcome rather than trying to regulate the whole thing with respect to the quantities. Okay, so then the question is, maybe it seems like a bit of a theoretical academic question, should you regulate the price or the quantity? So why are you talking about a carbon tax now? A few years ago, you were talking about cap and trade, which is a way of regulating the quantities. Why do economists talk about regulating the prices? And is it better from an economic point of view to regulate the price or the quantity? Well, here I'm just going to try to jump to the core of the issue for CO2, since that's the issue that's on the table more than anything else. The key issue is it depends on how steep that demand curve is. Um, if you have, let's say the demand for jewelry, we'll go back to that example. economists would say the demand curve is not very steep. If the price goes up, demand drops quite a bit because nobody really needs it. But energy is different. Energy has a very steep demand curve. In other words, as the price goes up, people don't really cut back very much. They just make more room in their household budget. They spend more. So gasoline is very expensive now. But if you look at the market data, the demand for gasoline hasn't dropped very much in the United States. People are paying a lot more for it because they really depend on gasoline to get around. And they've cut a lot else out of their budgets in order to make room for gasoline. So from the regulator's point of view, the question of how steep the demand curve for emissions is going to determine whether you want to address the price or the quantity. If the regulator decides in terms of CO2 emissions, I don't want firms spending more than $25 a ton on abatement, and a regulation is imposed that tells everybody they have to cut their emissions back to E1 in that diagram, then the problem is that while firm A can get there for $25 a ton, firm B is going to be spending $100 a ton. And then the regulator has to make a choice. Do I really care about the price, or is the quantity so important that I just don't care what it's going to cost? And it's this dilemma that has stood in the way of policymakers enacting the kinds of CO2 emission controls they've been talking about really since Rio in '92. So past 20 years, the typical dynamic has been policymakers and activists all get together in some sweaty conference room and they talk about, we're going to hit this 30% reduction target. They get all excited about, we're going to cut emissions, we're going to bring them down to 5% below where they were in 1990, or 10% or 20% or whatever the target is. And then they go home and they ask their officials, okay, how much is it going to cost to do this? And then they go looking at the CO2 emissions reduction costs and discover that these demand curves are very steep. In order to reduce CO2 emissions that much, you have to cut energy consumption quite a bit. And to do that, you run into fairly high marginal costs. And so then you have to choose, are you more interested in the price, in other words, the economic consequences of this policy, or the quantity? How important is that quantity target to you? Now, if I sort of jump forward to the CO2 case, the way economists would typically represent this issue is the marginal damages, in other words, the social costs of CO2 emissions, whatever the level is, they're likely pretty flat. So whether you think the marginal damages are zero, or maybe $10 a ton or $20 a ton, from the physical science point of view, US emissions in any one year don't have a big effect on the atmospheric concentration. So whatever the damage associated with the first ton of emissions, it's roughly the same as the damage of the last ton of emissions in any one year. So we would say the marginal damages curve is flat in economic parlance here. The curve, that the other line there, is very steep. So if you want people to reduce emissions of CO2, you've got to be prepared to impose a very high cost. And, if you pick a quantity target without thinking about it too much, the problem is the price that's implied, associated with even a small reduction, could be much higher than what you had in mind. Europe runs into this, you see. They impose the emissions trading system. They decided, we're going to regulate the quantities. We don't care what it costs. We're just going to reduce the supply of permits, and firms will have to pay whatever they have to pay. Well, the problem is that the price in the emissions permit market jumps every so often very high because of demand and supply conditions. And then European politicians are all starting to sweat because energy prices are jumping, firms are talking about leaving the continent, and you have economic consequences. It's to avoid those kinds of price shocks that economists prefer thinking about the price of emissions rather than the quantity target, at least in the case of CO2, because you're not going to make all that big a mistake in terms of economic impacts if you pick a price rather than a quantity. Now, having said that, and I'll make a couple of comments at the end about carbon taxes, the other point that's got to emerge if the US is going to have a kind of a grown-up discussion about carbon taxes is Um, Anyone who advocates a carbon tax should admit upfront it's not going to lead to much in the way of emission reductions. So the point of putting a carbon tax in place is not to achieve big reduction in CO2 emissions. It's to put a price on the emissions. And whatever you think the right price is, so just take a number off the top of our heads, if we said $20 per ton is what we want people to have to pay for emissions. Okay, so legislatures put a $20 per ton carbon tax in place. Then if you go back and say, well, was that a successful policy? The economic answer is, if people are paying $20 per ton for their emissions, then it's a successful policy, because that was the goal of the policy. If, as a result, emissions haven't fallen, or they've only come down by 1 or 2%, that's just the outcome. That's just what the market had to say about a $20 per ton emissions tax. What you couldn't do, though, is say, we're going to put a $20 per ton emissions tax in, and then a few years later, we look at it and think, gee, emissions didn't come down by 30%. Therefore, the policy didn't work. Well, no, that's just invalid logic. The demand curve is very steep. People don't respond much to price swings in energy demand, at least in the short and medium term. So anyone who's going to advocate a carbon tax should be prepared to admit upfront, this isn't really going to reduce emissions very much. And that's not the point of a policy like that. The point of that policy is to make people pay a certain amount per ton for their emissions. And so that's got to be in the background of discussions of carbon taxes. Now, with regard to carbon tax, if it came up, I'd like to clarify here, I'm not actually advocating that the US adopt a carbon tax, but if you are going to, and you're going to use it to replace all of these other indirect measures, you know, the fuel efficiency standards and the light bulb standards and the washing machine standards and new source review and everything else that just layers on billions of dollars in redundant costs, then yeah, a carbon tax would be better than that. The real question that bedevils this kind of issue is, how should the carbon tax adjust over time? And people kind of throw all kinds of formulas on the table. And what I've been advocating the last few years is, okay, even if you could agree on an initial value for a carbon tax that you are happy with, or at least willing to accept, that tax, the future trajectory of it should go up with some measure of temperature that indicates the effect of greenhouse gases on the atmosphere. And my candidate measure would be the mean temperature of the tropical troposphere. You could come up with a fairly simple formula that ties the carbon tax rate to the mean temperature of the tropical troposphere, which is where all the models say should be the most direct and immediate effect of greenhouse gases. And that way, if greenhouse gases don't really have much of a warming effect, then you're not going to knock yourself out with an increasing tax rate over the next few decades. On the other hand, if greenhouse gases do have a big effect on the atmosphere, then it'll automatically start increasing the tax rate, and people will have to respond and start making long-term plans for primarily more expensive coal and more expensive carbon-intensive energy in general. Okay, so anyway, I've covered kind of a lot, and I'm sure people are beginning to lose focus here, so I'm just going to wrap up the presentation with a couple of summary points. If you use the pricing principle, either with actual pricing or just as a kind of a thought experiment, how would people respond to an emissions price? Based on historical data, if power plants had to pay for their emissions, they would probably install scrubbers, upgrade their equipment, maybe do some switching from coal to gas or something like that. But they almost certainly would not invest in wind turbines and solar panels and even efficient response to a policy that's strictly focused on air pollution measures, at least under any conceivable economic circumstance, would not involve wind turbines and solar panels, except maybe a few locations where they make sense economically on their own. Similarly, with households would respond to more expensive energy by reducing their electricity consumption a little bit, maybe, and then just paying more for their electricity. But they probably wouldn't go throwing out all their light bulbs and adopting compact fluorescents, and they wouldn't throw away their large screen televisions. A few years ago in England, there was talk about we should ban plasma screen TVs because they use a lot of electricity, and electricity is polluting, and this indirect effect. But really, if households had to pay a bit more for their electricity, they'd keep their plasma screen TVs. They might just watch them a little bit less. But other than that, there's no need for a regulator to go and ban these things because you have to let people respond to the policies in their own way, whatever works out best for them. Okay, so wrapping up with some concluding points. Since the demand curve, the demand curve for CO2 emissions is very steep, so under current technology, only small reductions are feasible at reasonable marginal costs. That's the basic constraint on any policy discussion to do with CO2. People who want to talk about big emission reductions in the short term inhabit a kind of fantasy world where nobody would really mind massive increases in energy costs. And I don't see that as a feature of the United States right now. I was taken in the first presidential debate where you seem to have an argument between Obama and Romney about who's the bigger friend for coal. Neither candidate sought, or as far as I can tell, received a mandate to impose large increases in energy costs. So if that's what they actually have in mind to do in Washington, then they need to go out and explain that to people. We could also just look over the past 20 years. Same true in Canada and Europe and everywhere else. The failure of these big CO2 treaties and these big policies is the fact that the political leaders make these commitments to targets without ever having an honest discussion with people about how much it's going to cost, and without really making a case that it's worth incurring all those costs. Okay, and wrapping up, covering a lot of ground here. Energy consumption is a marker of human progress. Restricting energy abundance will slow economic growth. Conventional direct air pollution can be decoupled from growth in energy use. Sort of parenthetically here, I know Al Gore right now is doing his dirty energy telethon, and that phrase dirty energy, I just, where has he been? Like he grew up in the United States during a time when you stopped generating a lot of air pollution as a result of electricity production. You really decoupled transportation and electricity from air pollution, and you did it very successfully. So it can be done, and you've done it, and Canada's done it, and a lot of other areas in the world have done it as well. Indirect air pollution can be controlled, but it's a trickier technological problem. Progress is there, it's slower and likely always will be. Principle of targeting, this just says when a whole bunch of policy ideas are on the table and people are putting all kinds of dumb ideas forward under the heading of sustainability and green energy and all the rest of it, just sweep them all aside. Ask, what are we interested in? Let's have a single policy instrument that addresses the one thing that we're interested in, and we're not going to try to get at it through indirect regulation. Principle of pricing says ultimately the most efficient way of dealing with an emissions problem is a price on each unit of emissions. And then finally, emissions, huge challenge. Emission control costs rise steeply. They're directly tied to energy consumption. So you can only expect small emission reductions at reasonable costs under current technology. And that is my memo.
Thanks a lot, Ross. It's quite interesting. I noted a couple of things earlier in your presentation that I want to make a question or two about. And one of the things that I was most interested in is early on you'd mentioned that you'd discovered, surprisingly, that economic growth and CO2 were not going up simultaneously as you expected them to. But in fact, CO2 went down as economic growth went up, and that was a surprise to you. Now, is that unique just to...
No, I need to clarify that. The graphs I showed didn't have CO2, carbon monoxide and particulates and sulfur dioxide. Very important distinctions here. Those go down, at least since 1970 in the United States. Particulates, lead, all the conventional air contaminants that you can control with conventional technology, they've been going down while your economy is getting larger. If I showed you CO2, though, it's gone up in step with economic growth. And the reason there is none of the scrubber technologies control CO2.
Okay, my mistake. Thanks for clarifying that. I do have another question, though. You had a graph on direct contaminants where it showed those emissions were going down, and those were the NOx's, the SOx's, and so forth, the particulates.
Yeah.
Has that had a role in, you think, perhaps changing the surface temperature record because we've had clearer air, which is allowing more sunlight to reach the surface?
I would expect so. It's pretty well known that the aerosol load in the air will affect it affects the optics, and so that's going to affect the amount of sunlight reaching the surface. And an extreme case would be the effect of a volcano that shields vast areas and causes surface cooling. So I expect that in regions where there's still a heavy aerosol load, and I guess sulfate aerosols is the real key there, that can have a local cooling effect. I'm a bit reluctant to say one way or the other, though, because I know only enough about the field of optics related to urban air pollution that some types of aerosols absorb infrared and heat up, and some will reflect the long wave radiation and cause a cooling, and I don't know which effect would dominate. And also I suspect in the US, just because of your low air pollution levels, the effects now are probably pretty small one way or the other.
Okay, we've got just a couple of minutes left. Any final concluding remarks or words you have for us?
Yeah, I just want to go back to the point about if we were talking about international trade or labor market policy or anything like that, there's sort of an assumption that economics makes sense. Economics is a set of tools for analyzing these. But when you get talking about environmental issues, suddenly there's this halo that goes around the whole discussion, and you're not allowed to talk about economics, or it's assumed that economics doesn't really matter. And I think, though, you have to realize economics is going to emerge in the discussion one way or the other. And it usually comes in the form of if the policies weren't thought through in terms of economic efficiency, you either pay a lot more than you needed to for what you accomplish, or you just don't accomplish nearly as much as you could have. And also, you can get an outcome like we've had in the case of climate change, where people make huge commitments without really thinking about the costs. They never get a mandate to incur the costs. Those costs, though, are very real, and people perceive them, and the analysis shows them, and then the policy fails as a result. And we're going to have another 20 years of frustration and wasted time on issues like climate, as long as we keep going through this process of discussing it as if the economics somehow didn't matter or was irrelevant.
Sounds like we've got a bit of a rocky road still ahead of us on policy issues. Dr. McKitrick, thank you very much for joining us here on WUWT Live. This was recorded earlier because Dr. McKitrick couldn't make the live broadcast. I want to point that out to viewers. We'll be returning with more information and more interviews right after the intermission. Thanks for joining us.
Thank you.